Welcome everybody to Chicago JavaScript. Hi, I'm Justin. It's also Shankar or MPCon at various times. He's actually doing a lot of work, most of the work these days. I want to make sure he gets credit for doing all that.
No, thank you for doing something.
Even though I still tend to do these announcements, just been preoccupied with other stuff. So I'm extremely appreciative of him, and we'd love to have other help to make sure that if he's offers something, things actually get done. Also, we're things happened, and we're extremely grateful to Peter and Actualize for giving us a new home. Or change of pace. And you want to say anything?
Yeah. So thanks everybody for coming to our space. Just wanted to say a quick thing about Actualize, in case you don't know. We're a programming boot camp, a 12-week program, like a lot of boot camps. There's two things that make us different from a lot of boot camps. So we work with students who have lots of different backgrounds. Some have computer science degrees, some have never programmed before. It's a 12-week program, but ours is a part-time program, which is one differentiating factor, and another is we only hire instructors who actually have teaching experience. So I'm an instructor. I have a master's in education. I taught high school for 6 years. The CEO of the company has a master's in education. So that's something that we take very seriously in terms of having a high-quality experience for our students. We actually have two classes running right now. So if you look, we have some students off the side. They're working on their final projects, and they're going to actually have their final presentations on Thursday, same time. If you guys want to come, it's a free event. There's food, and we have another class at the conference room there. So when you guys are done here, if you want to mingle, talk to some of the students, see what they're working on, feel free to do so. Other than that, I hope you guys have a good presentation and enjoy.
All right, thank you. As usual, they're providing space, they're providing food, so we just have to find speakers pretty much, and it's extremely helpful to us. All right. We're actually here for Stinka.
Yeah.
So first up is Brian doing all kinds of interesting things, all kinds of interesting technologies.
Yes, thank you.
All right, get away.
So who here has heard of blockchain? Ethereum? JavaScript? Oh, come on, guys. No, come on, raise your hand. Okay. I'm a JavaScript developer who's interested in the blockchain. I'm Brian Herman. My company's the Concept. Ethereum, Web3.js, which is the API used to interact with Ethereum. Passport, Express. Passport is an authentication system. Express is a server-side API for a post that gets it's like a framework. Node.js, everyone knows what Node.js is, right? Server, how you run it, JavaScript on the server. Ethereum is a distributed ledger that allows you to run scripts there. Scripts are smart contracts. Smart contracts are basically contracts that can self-execute themselves and do not have a contractual clause, because contractual clause is actually enforced by the contract. I mean, the program. Distributed ledger is a consensus of replicated, shared, and synchronized data geographically spread across multiple sites, countries, or institutions. So, the distributed ledger is spread across multiple computers, multiple different places, and they all agree on one state or truth. How does my authentication system work? Now, I copied this authentication workflow from Hyperledger. So I think it's viable for use. So a user first requests a wallet from the service. User receives the wallet. User uploads the wallet with the password that's encrypted with the login screen, and the user is logged in. If they lose the wallet, they are totally screwed. So I'm probably going to implement a user password system. So it would in the future. So it would be a little different, but First, you require Express. Then you have Express router, Web3. That's the thing that you interact with Ethereum, and this is how you connect to Web3. These two lines of code were really hard to figure out. I don't know why they don't have a Web3 and a new Web3. I think it's instantiating the object, but I just don't know why you can't put that all in one line. So how do you authenticate with Express? I use Passport custom strategy to create a custom strategy on Express. So there's this NPM package called Passport Custom Strategy. It allows you to create your own strategy basically from scratch. And I modified the serialize and deserialize user to decrypt the wallet and authenticate. This was the hardest part. I mean, it doesn't sound like the hardest part would be the serializing and deserializing the user, but in Express it's just very, it took me like a day to just wrap my head around. So basically, you guys see this in the back, or? See that? Is that better? Okay, good. First, you have the serialized user function. Done is just a callback to signify your. So you have null and then key, which is the key that they uploaded, and password is the user's password that they implement, that they provided you in the login screen. And you have the deserialized user, which does the opposite. Deserialize the user so you can access the user information in Express. So you first have the account encrypted, Web3, ETH accounts log encrypt, JSON parse, which just parses the key because it's this is a string and you have to put it into JSON. Now in the key, there's circular references to itself. Basically, they're pointers that point to itself. I haven't figured out how to deal with those correctly. I tried an NPM package called JSON Circular References, but it still didn't seem to solve the issue. So I need to take a look at that more.
Is that posted data?
Yeah, this is posted data.
Did you use look at the body parser module?
Yeah, I think. Oh yeah, I could look at that. Yeah, definitely. Yeah, the body. Yeah, I could look at that. The body parser module deals with circular references too. Oh, yeah, because I'm using body parser in Express, so I think the circular references aren't corrected. This is the custom strategy. This is the meat of everything. So if it has the key, convert the JSON from UTF-8 with the password and flash login. Else, you flash no password. Now, for this project, you do not have to use a private blockchain. You could run this on the testing, which is Ethereum's testing. It's just for testing. So, I wanted to use a private blockchain because Hyperledger used a private blockchain. They're probably smarter than me. So. To create one, you have to install an Ethereum client like Geth. Now, Geth is programmed in Go. There's no JavaScript Ethereum client that I know of. I mean, there's an API which you could probably make it, but Geth was the easiest one to install, and it had the most. It has the most. I think it has the most features. So installing Ethereum command line tools, commands, root cat Ethereum, root install Ethereum. And in Linux, you have 3 commands: install the software properties common, and enable a PPA, and then sudo apt update. Oh, this and sudo apt install. And Windows, you just download it and then run it, and you run get the command. So this is the command to create your own private blockchain. It's very simple. Just, you get the data VR, and the dot signifies the current directory, and the genesis just used. So this is the genesis that's used. The chain ID 15. This chain ID is important because that you're going to deal with that later when you start get on the command line, so you can run your RPC. Get also is a server, so it runs the RPC functionality on itself. So you have the homestead block, VIP 15 block, and 155 block, and 158 block. I think VIP is a form of encryption, but I don't currently use it, so the difficulty, that's the difficulty of mining. And the gas limit, gas is very important. So smart contracts, gas is what powers them. They're like engines. They need gas. And then you have two addresses, which both have a balance of 300,000 and 400,000. So who wants to do some what? Oh. So, yes, sure.
What happens if you increase or decrease those values?
Well, the difficulty, you'll make it harder to mine. The gas limit, there's just, it's a limit on the amount of gas that you can have in your network, so you can increase it or decrease it.
So, for example, decreasing gas limit?
Yeah, it would allow less contracts to be executed on your system.
Is that the same as decreasing the difficulty?
No. Difficulty specifically is only dealing with mining. You guys know what mining is? So mining is when you mine new blocks in the blockchain to create new coins. And I'm not sure about the free after the chain ID. I have to do some more research. But all this is on the Ethereum website, so they probably explain more. So who wants to do some live coding? Yeah. Oh, no, I want to keep on the back. What do we need first? You guys think we need first? We have node already. Second. Yeah.
Instead of an I.
Oh, we need this. Oh. I don't think I have this. Oh, we already have this. Next, so let's go install directory. I don't know why they don't use Yeoman. I don't know why Express doesn't use Yeoman, because Yeoman. Yeah, I'm gonna have to do this. There we go. All Express done. What do we need first? Two more packages. What is one more package we need? Yeah, W. Most importantly, passport testing. So I know I'm using ESU5. But it's okay.
Rename that variable on 9/11?
Yeah, what? Oh, yeah.
Oh, yeah, sure.
Now we got one. 3.
Yeah, I need to switch some of those. using capital Web3 to make the other one.
Oh yeah, you're right. Let's create a new route. Route. Name this. What do you guys want to name it? To request the wallet. That's what I think that's request.
Yeah.
What are you typing now? Yeah. It's going to be the route to that's the wallet. Response.
I guess I got here.
So now I will use Web3 to create a new wallet. This is random hex due 32 years. Or random hex creates a new
Right. So when you're calling that bar wallet right there,
Can't hear you.
when you're calling that bar wallet,
Yes.
is it calling that RPC to generate that?
Yes.
Right.
Yeah. So yeah, Web3 needs a connection string. This is the website with 8546, and that connects to your private Ethereum blockchain, which is located on this machine. Set content disposition because headers are.
Need a parentheses, Brian.
One other file. Where?
It's a send.
Oh. This part. So this requires the route, so import into this file. Now we name users. Wallet. Let's see the files. generated installs. It's a fave icon. Fave icon, it's a little icon that's in the left.
Tabs, bookmarks, the icon. Tabs and bookmarks and things like that. You get it.
You have to run npm install
Oh, yeah.
to package JSON.
Okay. Part of it, we need our view. Unfortunately, I picked Jade, which I don't know. I usually use handlebars. What are you typing in on the password? The password key has it?
Well, type to name needed a comma, so does name the placeholder need a comma? It looks like.
So what are we making? I'm making
This looks like a login form.
a login form. I'm making a login form. That's actually beautiful. Moment of truth. Yes, start. Oh, we got a password, right?
Hmm.
Did you change?
Was it easier? The opposite of that, easier access to the store or is it that way instead of having to do like
Changing the post request.
So what are you trying to figure out?
Yeah, just fixing the form.
Why do you have to do that?
Had some time with all.
yeah. We got towards the end of our project. We would sit down at the whiteboard for like an hour or two.
That was a GET request again. Did you have to reload?
Yeah, I definitely thought about it. I was like, it sounds like it's just by everything was simple. Things that I can't really learn.
Say like, I know that I need something, but I want to buy Target.
As opposed to a wallet?
Once you go to Target, remember buying this? Right. And then you go to like Jewel.
Right, man, I was thinking of the
Have the template, see what
if you're accepting the route.
Yeah, but the root, that's a root wallet. So wallet prepended to the required. Oh yeah.
set up a script to test it. So at the end of this project, we had like $1.
That took a lot longer. Let's just go to the full demo.
What do you? So we're back, or after the demo, what are we doing now?
Yeah, well, after the demo, we're just starting. After the demo, we'll be done.
Okay. So what is the proof of identity?
Proof of identity?
Yeah, I mean, it almost like we're creating a wallet every time.
No, you don't create a wallet every time. You keep the wallet on your computer.
Okay.
And then every time you log in with a wallet. It's like a private key.
Okay, but what proof of identity are you making to the website?
Yeah, it's true.
I mean, so are you like making a?
If you have an address, you can
Yeah.
extract information from it. I'll show you.
Okay. Yeah. So are you like you're signing a transaction with your wallet, and that's the proof of identity, or?
Well, you can do that. Yeah.
Okay.
That's a good idea.
Okay, yeah. Can you just give us the idea that the work process, other than like, since we are kind of out of time, so just walk through that what you're doing and what you're trying to achieve. I think that's better
So
for us to
basically, I wanted to create an easier version to work with of IBM's Hyperledger sock. Because I found Hyperledger sock to be very hard to set up, maintain. So I wanted to create it I wanted to see if I could do a part of it,
Oh,
but in less time and less lines of code. I find the IBM version is extremely. You can set it up, but the easiest way to set it up is to actually use Amazon Web Services to use their AMI, and then you get to use it. And there's little documentation on it, and it's just.
So you're creating an application that's going to do things with the wallet.
Yes, correct.
Okay,
correct,
so
yeah.
I saw authentication and thought that you were using that as part of it.
The wallet is like a global, like a God object on the Ethereum blockchain. So you can do anything you want. Not on you can do anything you want with their wallet, and you can like send transactions.
Okay, so you're you're uploading the wallet to management and then putting in the password to decrypt it.
Yes,
there.
correct.
Okay, cool.
Thank you very much.
All right, let's start switching computers, and then we can do some further Q&A while that's going on.
Sure.
Yeah, so make sure you're unplugged. Get in. All right, so any other questions about Ethereum and Passport and stuff?
Anybody mine Ethereum?
One hand.
Anybody spend a Bitcoin? or make any transaction on that?
Yeah.
Is anybody written a smart contract in Solidity?
That's something I should look into sometime. See what
Well, they have a web interface. It's called. Just go to Ethereum. It's called remix.ethereum.org.
Ah. All right. Are you ready to go?
Yeah, no more questions about Ethereum stuff?
All right.
All right.
Well, here's Josh.
Yeah, I'm Josh. We're going to be talking about measuring client-side JavaScript performance. So we had some server-side stuff there with Node. We're just going to be talking strictly about the client. Yeah. Let's get to that. So monitoring a client. So I'm coming from a server-side background. How many here are coming from like a server-side oriented mindset? People in front. Monitoring a client is not like monitoring a server. So when you're monitoring a server, they've been going on for a long time, much longer than programming in the browser has been going on. And so it's got a vastly more robust ecosystem. Things like you can get timing on a per request basis. You can use those timings to reveal load on a server. You can aggregate those values over time. You can compare values from today to yesterday to yesteryear. Your servers can self-regulate. So if you have things that are being overloaded, they can spin up sibling servers, stuff like that. And you can get insights into the memory of those servers. You don't get those things on the client. So what's the basic naive way of measuring performance on a JavaScript client? Basically, take a date, do something, take another date, and subtract those things. But what are the problems with this? One is that it doesn't get you down to something below a millisecond. Second is that how many people here are proudly supporting IE8? All right, me and Jane. How many people are here proudly supporting IE9? Holy shit, okay. All right, well, then some of the stuff won't be that relevant.
Find support.
Is it usable in IE9, your product? Okay. So we support, business-to-business customers, so we have to support IE9 and IE8 because that's what some of our customers only use. So anyway, you can't do date.now in IE8. Fun fact. So what if we want to get some fine-grained measurements? Like if something takes less than a millisecond, if something takes less than a tenth of a millisecond, if something takes less than 100. Well, in your modern browsers, modern being Chrome and Firefox, you get this nice flame chart. How many people have opened up their dev tools, gone to performance, and seen the flame chart? Cool. How many people want me to explain the flame chart? Okay. So flame chart, you have an execution of a function, this big yellow line up here. You have an execution of some child function it's calling, and onward down to the end of your stack, and then you come back up. You can't get this in Safari. You can't get this in IE. You can get some other kind of waterfall metrics about like how long it took to paint the browser, whatever. But this is kind of maintained for the sake of some developers on Chrome and Firefox. Not available to everybody. Definitely not available to you when you deploy your code to somebody's browser. Other things that are not available. If I have this function anonymous, so helpful. If I have this function anonymous and I want to see how long it took in this invocation, I can just click on it and get that information down below. If I want to see how long it took when it was invoked 7 times, and if I want to compare those values, I don't get that ability here. So we have some new stuff called a performance API. So in browsers above IE 10 and above, you can use a performance API. So with that, this is a globally accessible object, performance, with a lowercase p. So you can call window.performance, and you can do things like creating marks, measuring navigation timings, like how long did your page take to load in general. You can take things called measurements, which happen between marks. And this is something like that, where you would mark the start of a function execution, you would execute, mark the end, and then you would measure the distance between those two things, distance here being time, and you can aggregate those things, pluck one of them out, and now you have a duration. Benefits of the Performance API are that they're globally accessible. So I make a measurement somewhere in one part of my app, I can access that measurement somewhere else. They are also down to the 100th of a millisecond, and that is kind of varying depending on the browser. So if something takes 0.001 milliseconds, you'll get that value. And you can serialize these things, so you can persist them over time. Has anybody used the Performance API before? Awesome. Oh, one person. All right. Awesome for everybody else, because that means that you can actually learn something today. Any questions about just this concept? I'm going to be putting up all these slides later, so all these things that are blue, those are links. You guys can go read things. Yeah? IE 10 and above? Yeah, IE 10 and above. No, sorry. Chrome, yes. I'm going to assume that everybody's running Chrome in the last 8 years, and then it'll be supported on Chrome. Otherwise, yeah, what's up?
New durations of the millisecond?
Such as?
Either low nano or...
Yeah, so you can get down to the 100th of a millisecond. And anybody who's metrically based, I don't know what that is. Is that nano?
No, yeah.
Nanosecond. You can get it down to the nanosecond.
The maximum that I can set that second.
I mean, you can multiply your milliseconds, or divide your milliseconds by whatever number you want to convert it.
Okay.
So what I mean is, like, you get 1,000 milliseconds, you can divide that by 1,000 to get 1 second. So it's going to be reporting to you in milliseconds.
That's what we thought leap second occurred.
So in this case, you're measuring the length of a function, and a leap second occurs during your measurement?
Yeah.
I don't know. That's something for a live coding demo, if we can all organize ourselves around that. Question? No? Yeah, so that's something that's actually interesting. So that's going to depend on the browser implementation. But yes, in the most recent version of Chrome, it is a little bit unreliable depending on whether the user's computer has applied the Intel patch for that stuff. But for the purposes of what we're going to be talking about, namely like running JavaScript code in the client, it's not really going to affect it that much. All great questions though. And if you have any other questions, just raise your hand, because I would love to be interrupted rather than keep talking. All right, oops. So, a couple things about this, though, that I thought we could improve on are that this is a little bit verbose. I don't really like having to restate func every time I want to measure something. I don't really care that there's a number of things in this array if I just want the first one. So there's a little gist that you can get here that we use in our applications. It's just perf. But what it does is it handles supporting things below IE10. So when you're below IE10, what it does is it just uses that new date constructor to get things down to the millisecond. It also allows you to serialize things into JSON, so you can do things like store your last session in local storage and then access that later on and now compare the values from when you accessed this web page yesterday to when you access it today. It also preserves that functional API and builds on it a little bit. so that you can have some basic quantitative helpers like mean, max, standard deviation, that kind of thing. We're going to go over this stuff in a little bit, and also has some other goodies in there like measuring frames per second of rendering, stuff like that. And this is what that looks like when you're using it. Is now we've gotten this. I also stripped out all the comments, so that was a little cheap. But now we're just declaring that we're going to start a function measurement, end a function measurement, and get the duration of the last time the function was invoked. Cool. Cool. So now that we can get those things, when we get a duration, we're going to get a number of milliseconds. If we measure again, we're going to get another number of milliseconds. Measure over time, we can get an array of those. But it's a little bit opaque to get anything usable out of that information, right? How do I make decisions based on information? So one thing that we started doing is setting thresholds. So let's see, if you're rendering normally at 60 frames per second, how long should a traditional like animation frame take? 16 milliseconds, right? 1,000 divided by 60. And what, or not by 60, but whatever. 16 milliseconds for a frame is normally what you want. So now what we do in our code is if something takes longer than 5 frames to execute, it's going to be a noticeable stutter in somebody's usage of our application. So we set thresholds. And now we can have warnings in our console when you're scrolling through the page and something's listening and takes 83 milliseconds to render, it will throw warnings at you. And if we're collecting those warnings, we can report them somewhere. So who's using Google Analytics? Cool. Who's using custom user timings for Google Analytics? Who knows what a user timing is in Google Analytics? One person. All right. So if you're in GA, I'm going to call it GA because I hate saying those words. If you're in GA, you know, you can see how long it took for your page to load. Well, that's one thing that Google's tracking for you automatically. You can report timings on whatever you want. You can report how long it takes for me to scroll halfway down this page. You can report how long it takes for some function to execute, in this case. So here's a link to reporting user timings. It's real simple. But basically what you say is, I want to track that this thing took this long. And you report it in milliseconds. And we do this now in our Redux application, which we'll get to in a little bit, to record a chart of how long our application takes to execute different actions, depending on the machine, depending on the time of day, depending on the load of how many people are on the site. All that stuff is already aggregated for you. Cool. And then the other thing that we have here is, this is just a little fun thing, but there's this little library that this other person wrote and I kind of branched off of a little bit called console.sparkline. And what you can do is pass in an array of things and it'll generate a little sparkline for you, which someone else pointed out to me earlier today is not super useful, but it's nice to look at. Has anybody ever rendered something like this in their console?
Not like sparkline, but yeah, other color.
Other colors, cool, right, styling, right. So that's with the %C operator. What's really cool, and I would love for a lot of other people to experiment with this is actually an SVG. So you can log an SVG to the console and it'll render it in line. So have fun with that idea.
Do you use this like with React Native?
I have not used it with React Native. I use it with React all the time. You would need a browser console in order to review this stuff. Questions? I don't know. That would be a great experiment. I highly doubt it. But yeah, so for example, here, this is an action, this success get category products, that's an action that goes through our Redux middleware. And so what I'm going to do here, what we're doing here is getting all the entries for that action that happens hundreds of times in our application. And we're going to get the duration for all those, and now we've got an array of milliseconds, numbers, and then we're just going to sparkline that stuff down here. And so what we have now is whenever an action in Redux takes a certain length of time, it will log a warning, it'll log a sparkline so that we can see, oh, is this trending upward, is this trending downward, does it happen on spikes? Okay, if it happens, you know, in 2 large spikes here, at the beginning and at the end, what was there? And now we can go back in time and look at the exact timestamps for all those different marks that we took and see what else was affecting that. Which gets to another thing, like what affects the speed of your app? And so the first thing I want to point out is that the #1 offender of your app speed is your code. So address those issues before we get into anything that we're going to talk about later. So what you should be doing or what we have started doing, is using this performance API to start measuring how long different function signatures take. So, for example, instead of mapping through every item in an array to pluck, or instead of mapping through every item in an array to filter out the ones you don't want, or to find one thing, maybe you just use a plain for loop. Maybe that takes two orders of magnitude less time than another thing, which is exactly what we have found in a few different cases. So, first things first, improve your code before you go throwing stones at glass houses. But other things do affect your code. For example, if you're going to be accessing the DOM, #1 offender, other operations happening on the page affect you. So, for example, if I have some browser extension that is constantly polling Ethereum or if I have some malicious code that's polling Ethereum to mine stuff for someone else's benefit, that's going to affect my app's performance. Other things happening on your domain. So, depending on your browser, I don't know if I've mentioned this a couple times previously in talks, but it's really interesting to me. If you have two tabs running the same domain, you share either a thread or a process depending on your browser. So be aware of that. Meaning that you are going to be governed by how many other tabs somebody has open for your application. Other operations happening in your client's browser in general. So if I have Gmail open, it's going to be slowing down my tab somewhat. If I have other load happening on the client's machine, if the client's machine is a piece of crap, it's going to affect my app's performance. And so the upshot of all these things is that measuring a single performance mark-to-mark measure is not going to be sufficient to make decisions in your application. So what are we going to do? We're going to aggregate some measurements. And so now we're going to get to what I was describing before. So we can get a sample size for our measurements. We can calculate the 95th percentile to see how widely varying this stuff is. We can calculate standard deviations. We can calculate averages. And now we can start getting into measuring maybe over the course of a 30-second session, how widely does an action vary? Any questions on this stuff so far?
Sparklines do like curves, 95%
I don't have a picture of it, but yeah, you could absolutely do that stuff. I've been developing these things in the last couple of weeks. So I don't have like a ton of examples. Yeah, question.
Yeah, so like, how do you have to go into like statistics to understand how performant your clients are?
Sorry, how do you go into
No, how
statistics?
deep you have to go into statistics? I mean, those are just the basics.
Right.
Right. So like, you have to know a lot in order to do this also?
I mean, I don't know a lot in order to do this stuff, but you can get as deep as you want, right? So one thing that I started, an idea that I started with in this case was that difference that I was outlining at the beginning, right? Where I have servers that know about other servers and what they're doing, right? I have servers that can respond to load and scale themselves up or down. Why can't I have that on the client? So the first step is to be able to aggregate these measurements and make decisions off of them. Now we're going to get to what you can do with some of those measurements in aggregate. So one thing that's at the end of the spectrum, which we're not going to get to, but I hope to at some point, is what happens if you have, if you're using WebGL, so you're using the GPU of the computer to train a neural network that is taking these measurements in and being able to predict how long an action is going to take before you actually take it. Right? Like that would be really cool stuff. And hopefully we're here in a year and I'm able to talk about that, but I'm not. What's that?
They have a JavaScript that might say genome cancer.
Oh, I know. That's what I'm talking about. And it uses WebGL to access the GPU of the computer. But that would be really cool, right? So we're going to get a portion of the way there today. So to that point, what are self-managing clients going to look like if you can measure the internal performance of your application? Can you make decisions based on, okay, we saw this action 5 seconds ago and it took 5 milliseconds, and then we saw it 3 seconds ago and it took 15 milliseconds. Can we predict it's going to take 30? Can we do things like delay or defer actions because it's A, not necessary, or B, going to have a taxing effect on your interface experience? So how many people here are using Redux stuff? All right, cool. Of the people who are not, who wants me to go over an explanation of what Redux is? Awesome. Okay, I'll go over basic one. So basically, Redux is a system whereby you maintain a state, you apply actions to that state, it functionally transfers that action through multiple different state reducers, spits out another different state on the other side, and you can register middleware that perform different things based on those actions coming into or out of that state. Anybody disagree with that description? Awesome. That's the first time. But because we have Redux, we can apply middleware to those things. So similar to how in Express we were going over that passport middleware, you can do things to the request before it happens or after it is processed by the internal server. In Redux, we can do things before or after an action is processed by the reducers. So one of those things you can do is measure how long it's going to take. So this is the thing I've been referencing. This is the middleware that we run on our Redux applications right now. So basically what we have here, I'm going to go through a little bit slower. So we have a threshold of 5 animation frames. If something takes longer than that, we're going to call an error and throw a warning. This is simplified function signature for middleware. Point that we should take away is that we're going to start measuring an action before it's applied to the Redux state. Apply it, and then we're going to measure, that would mark the end of that and create a measurement of the duration. Okay, duration. And if our duration is within our threshold, we can skip it. Otherwise, we're going to log things like how many sample sizes how many samples have we taken so far? What's the standard deviation? What's our average time? And then we also, I skipped it out. I took it out of here for simplicity's sake. But we also want to start reporting this stuff to something like Google Analytics or other metrics aggregators for us to be able to perform, visualizations based on this stuff remotely from the client. So now if we have this and we're running Redux on some IE8 machine, I can see that this rendering of some category products on a page takes 5 times as long as an IE, and I can go diagnose that without anybody having to report to me that our app is slow or anything like that. And I can also, if I start doing this at the beginning of our project, which we have been doing, we can see this either grow or hopefully, if we're really good, shrink over time. Is anybody collecting quantitative metrics or metrics around app speed right now, remotely from clients? Well, how are you doing that?
I use Python interpolator for my server-side code. So I decorate all the functions I want to perform metrics on, and just collect it in CSV.
Are you doing that for your client-side JavaScript?
Oh.
We're using New Relic to capture really high-level stuff like page loads.
Gotcha. Yeah. If you use the performance API, that's already built in, so you don't have to incur any overhead if you don't want to.
Yeah, I wonder if they're using this under the hood to capture their metrics.
Probably are.
Probably are.
I would hope that they are. Other questions? Yeah.
Do you find that you have to write Redux actions just to take advantage of some of the performance measurements here, or are you able to fit this into
I mean, this is like a drop-in middleware that we use right now. I don't find myself writing actions to take advantage of this. Basically, we have things like an action that says, I'm going to make an API call. We then have an action that says, oh, this is the result of my API call. When that API call comes in, since it's Redux, it's going to have to go through and update all the components that are listening to that and rerun the page. So now we can say, before this payload basically is being applied to the page, how long does that take? And those things happen. We have hundreds of API calls that happen in our small to moderately sized app. And so we're able to aggregate those things now. Does that make sense?
Yeah.
Yeah. On the server side? No, well, some of them are, but they're also being the warnings. So we're mostly throwing away everything that's not an issue, but also the warnings and stuff. We're reporting those to GA, to Google Analytics. Well, no, they're actual individual timings. So for each one that's an error, we'll report that, or for the ones that are if we wanted to report good ones too, we could report each individual one as a separate GA tracking user timing variable, and now we can see that stuff aggregated. So for example, one thing that we started using this for was we have a client-side live search, right? So big catalog of products, as you type, we search through a bunch of different fields on those products. It's like Elasticsearch, but in the browser. And we're recording for every keystroke, how long does it take to search through the corpus of products that we have. And now we're able to see that go up over time, either linearly or exponentially or logarithmically, according to how many products are in our catalog. Stuff like that. Does that make sense?
Well, even with only like clients that are in America, because like the UK data protection laws, do I have to show a data protection thing?
I am not giving legal advice. If you are in Europe, show the cookie disclaimer or whatever. Right now, I'm assuming you have permission to collect data from your users, or not permission, no legal prohibition. Yeah.
Are your points limited to React at all?
Any of it to React?
Like,
Yeah. So, I mean, with this idea, I don't have an example right here, but you can think of a high order component basically that will start a measurement before rendering its children, create another mark after rendering its children, report that stuff back to you, right? So there's actually I don't have it linked here, but there's a relatively developed browser plugin, Chrome plugin, that will do that stuff for you. It seriously slows down and screws with your app though, so I wouldn't recommend it. But that stuff is starting to get developed. So yeah, you can do those things. For that product search that I was describing, that live search, that's how we're doing it. It's a component. It measures the length of time it takes to perform one of those searches. Yeah?
Question. You gave an example about like the search, right?
Yeah.
Search result, but the reality is the backend.
No, that's all in the client. It's not making API call.
So you store a big list of products in the client.
We store an inverted tree index actually in the browser memory. Yeah. Good question. Yeah?
Could you use a higher order component and your performance code to every function in the
Yes. I don't think I'm going to do that. For the reason that I was describing with that Chrome plugin, right?
Oh.
Where it's like, it seriously slows down your app just for the possible benefit of measuring like some really slow components. Whereas I find it more fruitful to take, so like we do this for all of our actions because normally that's the most expensive part of your application is when something's actually happening. But for a lot of your components, they will have like scroll listener or some other thing. I don't really want to attach a listener to the hundreds of instances of components that are on my page. Instead, I normally will target one and say like, hey, this is something we're building. Let's quantify how much it's actually going to slow down our page. Something like that. Cool. So, with this in mind, that we can have introspection into how long actions are taking, this is, again, still just reporting this data. What happens if we use this data inside the application to inform the application's decisions? So, this is a self-throttling Redux middleware. I'm going to go over why this is a stupid thing to do in a little bit. After I explain it, someone maybe will explain to me why it's stupid. But basically, what this is doing is I'm using this little perf goodie that we have on this library that's in the gist, and what it's doing is it's measuring frames per second. So this little on FPS handler is going to get called whenever it is able to request an animation frame, and basically what that's allowing us to do is calculate a lag. So if we have more, or if we have fewer than 60 frames per second within an interval, we're going to count that as lag, right? So that was time in which the browser was spent doing your JavaScript calculations instead of rendering something for the customer. So again, we have our threshold of 5 frames. We're going to, before performing any action, we're going to calculate what was the previous duration for this action type. If the action in consideration has not previously been delayed with this little private property, which, yeah. If it's not previously been delayed, and our lag on our application globally is currently over 5 frames, and our previous duration for this action, last time we took it, was over some threshold, let's delay this action. Why do we need to do this right now? So now we're going to delay it by some truth. We're going to mark it as some delayed truthy value. We're going to set a timeout of some lag, and then we're going to dispatch this action again, come back to me in 5 milliseconds or something. And then we're just going to return our state unmodified. So let's say I'm coming through Redux, and I have a thing that says like, oh, open a modal. Well, if it's currently having problems processing your application, we're going to bounce this back out, come back in 5 milliseconds, and then now open the modal. And again, we're going to measure how long it takes to apply itself to the state. So does anybody have an idea of why this is a stupid thing to do? I actually did this for our application. I didn't deploy it, but I thought this was a good idea before I tried it out.
It's slow and you're making it even slower.
Bingo! This is slowing things down for no good reason. So,
Isn't another problem that it like to reorder your actions?
Yeah.
Yeah.
Another good thing. So, for example, for every one of our API calls, we make an action that says signaling, I'm going to make an API call. And we have an action that says, I'm done making an API call. And we have a thing that says, this is the result of the API call, right? If you get those things out of order, you could have a different state at the end of that. So, not a good idea. But something that's, I'm hoping this is a taste of something that you could do if you wanted to with some interesting React middleware. Maybe you could have an idea of actions that are, so I haven't tried it yet, but one thing I was going to try to do was having it so that an action can have a property of like nice to have or some more eloquent wording. And if it's nice to have and your application's under duress, it will delay it. And so things that are API calls aren't nice to haves, but things that are animating a scroll bar are nice to have. I don't need to do those things. There's some interesting writings on this stuff. I just read one today about the draggable React library that had to do a whole rework of their Redux flow because they did some introspective calculations like this. So I think this is definitely worth some of our time.
You try making like a max threshold, but then instead maybe like instead of delaying it for like a few seconds, you like exponentially increase it to like 2 at threshold.
Back off. Yeah, you could do something like that for sure. Cool. So a better approach than the slowing things down that are already slow are being able to degrade gracefully. So things like removing ornaments. For example, we haven't done this yet, but we were just talking about it today. We have a big D3 chart, multiple D3 charts, that all have some animations that come through. Those take 3 seconds. If we're running on IE8 and things are taking 100 milliseconds to go through our Redux stores, let's not animate things. Let's degrade gracefully and remove some ornaments on machines that are having problems rendering our application. We can also simplify some animations in general, removing those scroll bars like I was referring to. And we can also throttle some event listeners. So, for example, if you have a scroll listener, big one, just reduce the number of, increase the number of milliseconds between checking that stuff. We have a bunch of listeners that are listening to like browser resizes. We can throttle those things down. So that's what our next approach is going to be for using this information to self-govern an application. So in summary, collect fine-grained measures. Aggregate your data instead of having one single snapshot like those flame charts and Google Chrome would have you use. I think that aggregating that stuff and then storing it would also make for interesting stuff. So one thing that we've not done yet that I was referring to is what happens if we store your last session performance timings as a simplified or compressed serialized array. And now when you restart the application, reread that stuff and make informed decisions based on how your last session was. Those things are interesting. And I think that we should start, as people start putting 7, 10, 17 megabytes of JavaScript in the browser while running at the same time, I think it should be part of our tools to make the app responsive to the actual performance of the machine. So this was a big battle. I don't know if anybody was here when responsive design was first introduced, but yeah. So I'm starting to think of this as like, not responsive design, but responsive performance, right? So depending on the person, on the machine's capabilities and already like existing load, we should be able to have our application degrade or improve dramatically. That's it. I'll put these slides up there. Any questions on that stuff? Awesome. Question in the back. No clapping. Question in the back.
I was wondering, what other source of data is there for things like uncappable?
You don't get it. No, you don't get it. I mean, so one thing you can do, so you can have information about your own domain, right? So 2 things, sorry. You can have information about your own domain. So that's the thing that I was referring to with like your domain in multiple tabs shares the same either thread or process depending on the browser. The reason for that is local storage. So when you write to local storage, it actually broadcasts an event that says some shit in local storage happened, and it's an event called like storage event. And what you can do is listen to that across any tab that is currently open with that. So if I have 2 tabs open, I can theoretically write to local storage with something. You can get that event in a handler, read what was written, and now you have message passing between tabs. Theoretically, you could use that to do something like this. Second case where you can communicate between those tabs, theoretically, it's not necessarily a tab, but you can communicate over iframes. So that's called the post message API. Has anybody used that before? Person? Okay. If anybody ever writes a Shopify plugin, that's like their entire plugin architecture. It's posting messages between iframes, and it's horrible, but it works. So it's essentially like, instead of calling an HTTP request, you basically send, this is a string, and then it gets to your iframe. But other than that, I don't know of any others. I don't know if anybody else knows of any other ways that you could communicate between tabs or anything. Yeah, no. No. Yeah, sucks, right? No. I mean, honestly, like I would prefer there to be less information available about other things that are happening on my machine, because that's how like fingerprinting happens, right? So this performance metrics, somebody wrote a proof of concept, I think last year, where if you run a specifically, it's a little bit like the meltdown stuff, but like basically what you do is you write a very expensive loop in your JavaScript, and you measure how long it takes to get to different points in that loop, and now you have a fingerprint about somebody's machine, and it's like 75% of the way there to doing all the other fingerprinting stuff that you're currently doing, which is great. Other questions?
But how many tabs are open? You can measure from the server side. So every tab is open.
Oh yeah. Of my website. Yeah. But not of other people's websites.
Then you do the plugin.
Right. Yeah.
Do you think it'd be useful, like if you're on a development team and you use like a lot of analytics, would it be useful for your performance advice like that?
Absolutely. I haven't done that, but you should, and then come up and talk about it.
Server side, sorry.
Okay. Other questions? Yeah. Yes. Yep. Yeah. So what we do for our logging stuff is we have a single abstraction for logging, and what you do is whenever you actually want a console log and anywhere else in the application, components, reducers, actions, other things, you import that logging library, and then it has the same interface as console, right? So console log, warn, info. But what that logging library does is it has switches based on like the environment that it's running in. So if I'm running in development, log at this level. If I'm running in production, log at this level, throw away everything else immediately. If I'm in, whatever other environment. And so then what we can do is tune it based on query parameters or other variables in the console to log appropriately and not slow down the application in production. I think is what you're kind of getting at, right? Yeah. Cool. Other questions? All right. Yeah.
Have you thought about like splitting work? So that's what I've seen before. Like I had an application where you run a news feed, and it basically is scheduled multiple events to render each element. So and this way you don't block the thread for a very long time.
Yep.
So that's something.
Yes.
Sometimes do.
And that's kind of what React is doing for you, right? Is they're batching updates together for you.
Yeah.
You can do that yourself if you want to set timeout and like render something later. One problem is, so who here is familiar enough to explain the JavaScript event loop? All right, so I'll do a talk on that sometime.
Oh shit!
But it's super important for things like this, right? So basically, what that means, what I'm kind of getting at is like, depending on the Sorry, did you raise your hand as somebody who understands it?
Yeah, I think that is.
Okay, cool. Okay, but then I won't explain. But basically, the reason that set timeout isn't always going to do what you think is because the event loop batches timeouts and intervals together.
Okay.
And so if you schedule like 5 of them to all set timeout in like 1 millisecond, they actually might going to happen at the same time.
Like you could schedule them after each other. So one is finished, you start the next.
Yeah, for sure. And then you're kind of slowing things down that are already slow.
Yeah, but you're not blocking the user from scrolling or anything like that.
True. Yeah, you're not blocking, but you're also not really benefiting anybody, right? You can try that Redux middleware. I thought it was like I spent like an hour trying to do that, and then I was entirely crestfallen when it just slowed everything down. otherwise. So, but do all those experiments. Any other questions? Awesome. Okay, thank you.
All right, thanks for coming out, everybody. I don't think we have a topic for next time yet, do we?
Yeah, we do have. I
Okay.
didn't announce it yet. So next meetup would be in the Innova office in February. We have one talk for that. So
Okay.
we'll post it maybe this week sometime.
Okay. Yeah, excellent. But yeah, we're always looking for more stuff for future meetups. Please let us know if you've got any cool ideas. Thanks for coming out.
See ya.
Let's get